Yeah, go ahead.
It's Dan, right?
Yeah.
All right, I quickly looked at your profile on LinkedIn, it said you were with Station 5 lead developer. Were you involved at all with their threading efforts there with direct 3D command lists?
You know,
I'm sorry.
I can't comment on 2K products. This is not a product for.
Well, I'm just looking for your perspective. If you were somebody who worked on that, and then
I will say, let me just phrase it. I can't comment anything about 2K products. However, I have a lot of experience trying threaded processing and command buffers, and have done it in previous products.
And so based on your experience, you're finding it really has not worked out very well.
Yes, based on
okay,
my
that's
experience.
what I want. Thank you.
Okay.
Based on my experience, it's the same.
Agreed.
Sure.
One of the talking points for Mantle has been that it allows you to use GPU resources more efficiently. Does this have an impact on how much memory a game uses to run in any way? Does it actually maybe possibly use more memory because you're using more resources efficiently to do your data computation? Does it let you take better advantage of what's available?
Is that directed to?
I think it's just a law.
Anybody?
General question. Who wants to
I have
answer?
one comment, I guess. It's yes and no. It can take more memory because we could utilize larger memory pools for various types of optimizations. But on the other hand, one of the things I mentioned, for example, with transient resources, we can actually significantly reduce the amount of memory we use as well by only by more efficiently sort of sub-allocating within larger memory use, and that's quite interesting. So overall, I think we'll actually use less memory.
Okay.
Yeah, I would agree. I think overall, yeah, I mean, the API will allow us to use less memory. If ultimately we then decide to do more stuff, then yeah, we may use more memory, but effectively we're reducing memory pressure due to using the hardware more efficiently.
Well, one of my questions would be, let's take the 7970, and let's say further that a regular 1080p game today is using 1 gig of memory, but that's a 3 gigabyte card. Does Mantle give you guys sufficient control to sort of say, okay, if I've got 3 gig of memory and I have if I have a 3 gig card and my game normally uses 1 gig of memory, can you use Mantle to sort of take better advantage of the other 2 gig that would otherwise go unused?
I actually have an anecdote about this. Just before, I created a texture that was slightly bigger on one boundary, and then what happens in Mantle is it actually tells you how big your texture is going to be, which is something you don't get in other APIs. And so it turned out that instead of being 5% bigger, the texture was actually 3 times bigger. And that was just the constraint of the hardware. And because I was able to see that, I immediately looked at it and said, oh, that was stupid. Let me just adjust this texture size a little bit. And sure enough, I saved like 200 megabytes or something crazy. So I think the answer is yes, when you can see how its allocations are happening and you see the way the memory is, there is a level of tuning that you can do that is kind of unprecedented for a PC developer, and you can probably, we didn't spend a lot of time tuning it, but I would believe you can do a much better job tuning memory usage scenarios.
Yeah, PC these things on the experts or DL, these things are very approximate. Otherwise, we guess how large our resources are, which is usually an ideal view of it because it's hidden by the driver and it has lots of special cases for it. So we get to how many megabytes you have on your graphics cards, and we guess how big our textures are. We try and match them very approximately. Here we can actually not just guess. We can
You're
actually
not guessing,
measure
and if you make a mistake, you can see it.
Yeah.
David?
So one question I have is, so if you're getting rid of the driver layer, right? DX comes with a lot of like built-in counters and debug tools, and right, it's an entire environment to some extent. So I guess one of the things I'm wondering, and this may be also an AMD question as well, but what does the profiling and debug environment under Mantle look like?
All right. I think I addressed this a little bit in the talk. That we have taken all this tool-related and debug-related issues extremely seriously. Mm-hmm. So we are building an infrastructure within the driver, an API that should be the best one out there. And actually, this is the most complex part of the driver because everything else is very lean and mean. This is the beefy part that provides a lot of safety and all the features of profiling, for example, what we've built right into the API is what already is there in other APIs. Yeah. On top of that, we are including some extra features for hardware profiling. that are not present in other APIs. So they might not be present to the same extent. And just to give a little bit of my background, I come from not only ISV support, but also from the driver optimization. And I was doing a lot of, before switching to Mantle last little while, I was doing a lot of profiling infrastructure, all these counters on drug tags, and other things. So believe me, I've taken everything I know and more and put it in the Mantle as
So
well.
is that gonna be integrated into, I can't remember the name of the AMD tool, it's like code, not code analyst, but.
Perf Studio,
Yeah, is it gonna be integrated into Perf Studio?
yes.
Okay.
So we are very serious about tools, and we are making, while I can't give you specific dates or feature sets and whatnot, we are working on the tool set that would be great complement to Mantle.
In addition, I will say that we do a lot of extensive CPU profiling as well, and without any of the additional tools, the existing CPU profilers that are out there, we're getting much better information regarding what's actually happening. I mean, when we call it a big black box, it really is.
Giant box.
It is a giant black box. So I was actually fascinated. There were calls that we were making that I didn't even know existed until I started profiling. So it's been really, really nice.
And this is actually one of the fundamental things that what we've tried to do and really addressing what developers wanted to see. It's not only getting out of their way, but doing it in a way that is transparent. And there's actually a lot more transparency in how we do things. And I think Dan or you Jim have kind of hit on the point that there is a contract between us and developer, right? Not only do developers guarantee that they won't do bad things, right? And they take on some extra responsibility, but we also guarantee that because your guys not doing this, we are not introducing any safety factors. We are naked, you know. You just go directly to what we promised the functionality is.
So I would also like to add, you started out saying like DirectX has all these debugging capabilities and profiling capabilities, but I would actually say in our experience, I think we've talked about DirectX being somewhat stagnant in terms of how the API has evolved, but I would actually say that the debugging capabilities that DirectX exposes are, especially compared to some other platforms, are actually rather poor. So I think it's also a great opportunity to, as well as evolving the API itself, also the debugging capabilities will evolve, and I see no reason right now to not actually assume that they would be better in Mantle than what we have in Dart 3 right now.
Charlie?
Yeah, this is probably for the Oxide guys. At about 5:31 into the demo, one of the ships turned. Just kidding.
It's his fault.
I believe it. No, actually, this is for everyone. Generally, when you rev an API or whatever tool set, you move the bottleneck. You don't necessarily, you fix a problem and that just moves the bottleneck. Does Mantle, in your opinion, move the bottleneck to a more temporally appropriate point, or does it allow you to set where the bottlenecks are?
That's a complicated question.
I tried.
It's a good question.
Our data
Sorry.
is,
Yeah.
so far, we're still kind of playing around with it, and I mean, Gennady might have more information about it. I think it's going to shift it back to the GPU hardware architects, because it looks to us that no one ever expected to do these kinds of draw submissions or batch counts, and there probably are hardware assumptions that no one would ever exceed 100,000 or something. So probably there's gonna have to be some thinking about, and there are probably simple things that can be fixed or adjusted, so that the limit is probably going to physically be the actual hardware, not the software, which is where it should be. The limit shouldn't be.
So like the number of work items on the GPU and the workload in the work manager maybe?
Well, it could be anything. I mean, I
Yeah.
can't speculate to
When
what
they
it
say
is.
the appropriate answer is, we don't know yet.
Yeah.
Well, I can comment being a performance guy on the GPU side for a number of years. So certainly, I mean, you'll hit some bottleneck, right? And when we were talking about a small batch problem, right? It was the small batch problem. We didn't actually have to identify it as a software small batch problem, because this was the only small batch problem you had. Now you actually have to differentiate between software small batch problem and hardware small batch problem. And to give you a little bit more color to what this means, hardware small batch problem. 100K draws at 60 Hertz, it means you actually launch a new drop every 150, 170 clocks on the GPU. That's fast. Now, one thing that we could do, because a lot of the existing drivers, what we had to do is to optimize for the software overhead, and we could sacrifice hardware performance. Now it's very interesting to me as a challenge, how do I switch this around? I have some CPU cycles to burn. How do I use those to optimize the GPU performance, right? So this really opens up a new area of optimization opportunities, which I love.
I guess the same for us on the engine side also, that even if you're not doing 100,000 draw calls and become potentially bottlenecked by the GPU, for us, if you solve the small batch problem on the CPU side and we actually go wide with all our rendering, we'll probably be bottlenecked by, well, either the GPU, and people have quite high, not by draw calls, but just by, well, the GPU is running at maximum efficiency and rendering its frames. So you're either be bottlenecked by that, or you're be bottlenecked by the CPU. In our own game code, for example, not in the rendering code, but our game code goes really wide, but there's a lot of code there that's being updated for every single player at high frame rates. So, but I would love to be bottlenecked there, so we can actually see that and optimize that and work with that and actually utilize these multi-core CPUs that we have. So instead of having this big sequential part that you're being bottlenecked on.
So I think we'll make you guys much more optimal. We'll force you to be optimal.
Yes.
Yeah, I mean, I think the thing that's interesting is that because we have more control over how the application is working, if we're running into bottlenecks, that instead of being an external problem, it's now an internal problem, and we can adapt to that. So, I mean, if it is a small batch problem, then as an application developer, like maybe we'll decide to go ahead and do something different. If we are spending too much time on the back end, like, you know, even for the demo that we did, we added more levels of LOD because you know, at one point the driver had so much overhead that it was really pointless to put in lower LOD objects because we just couldn't draw them fast enough. It wasn't a GPU problem, it was a CPU problem. So as you move them around, there's always going to be different stuff that you're going to discover, but what I think is super important is that we don't have to wait for the driver team to possibly create a fix for us. We can go ahead and based on the application that we're making, because your optimizations are going to be different than our optimizations for a particular game. And even with all the different games you're making, they're still going to be different.
Yeah.
And now we can actually have some control over how that works. So.
And in the dark, we have no opportunity of optimizing your games to the same level, right? I mean, we just can't. We can only do safe and mediocre solutions. Whereas these guys, they can optimize to the non-stop.
Non-safe and non-mediocre.
Non-safe and non-mediocre.
That sounds like a great quote.
Is that word?
As long as I didn't say it.
I think in general, I think for you guys actually it is really, I mean you have an engine that is from scratch developed to be extremely multi-core. I think when you look at a lot of game engines, and there's a couple we've worked on, yes, as soon as we solve this problem, that was the biggest problem, yes, there will be new problems. So, but yeah, so then we'll have to solve those, but I think we have to start by fixing the worst problem. That's one of the things that's holding us back right now. And all you can do after that is starting to, then you can solve the other problems right now. There's even incentive to solve some of these because why would I make my simulation faster if I can't actually draw all these objects and so on different threads? So after we can draw them really fast, there's some really impressive numbers from the outside guys how fast you can draw them. It becomes an insignificant part of the frame, but then all these other things will hold you back performance-wise. So it's an evolution, but you need to start with one thing, and you start with the worst thing, and then you keep moving.
And as a reference a little bit, for the last year essentially, we've been working a lot on the next generation consoles and just optimizing CPU performance and over the overall system and building everything, optimizing CPU performance and trying to get to our goal of 64 players at 60 FPS. And now when we ship the game, we have around, in such a level where we actually have 64 players, we have around 90-95% CPU utilization on the next gen consoles on those 6 Jaguar cores running in parallel with our code. That's quite good. And we parallelize the rendering also even with the type of APIs they have out there on the console. So that's the type of thing I would like to see on the PC if you have a quad core or a 6 core or even beyond there. That would be very interesting.
Do you, if Mantle allows you to do more work as far as CPU optimizations are concerned, do you have to create the equivalent of, I guess, profiles for Intel versus AMD or Kabini versus Steamroller? Is it advantageous to you to sort of write code where it gets executed one way on an Intel chip and takes another path on AMD, while executing Mantle as opposed to running DirectX 11?
I don't think so. just getting rid of these large bottlenecks, essentially, these large sequential bottlenecks will automatically make a significant contribution in improved performance there. And then we'll see what the new bottlenecks will be. Maybe that if we get to, well, the thing I mentioned, 95% CPU utilization on a 6-core machine, well, we'll probably hit completely other bottlenecks. I think most people will probably be bound by their GPU because they want to run with really high settings and high resolutions rather, which is great motivation to create faster GPUs.
Actually, if I put my ISV hat on, so don't look at me as AMD driver engineer, but graphics is one of those problems where it's easy to scale, right? Because you have a lot of eye candy. So one thing that developers have been doing is, what is my far clip length? Right? What is my view distance? And quite often, they've scaled it quite a bit. So maybe on a system that has a little bit more headroom, you just push it out. So you have a much better vistas out there. It's one of the ways, or maybe pushing more effects. You guys have been talking about some cinematic effects. And
Yeah, I mean, we'll do more motion blur frames. We'll shade things at a higher quality level. There's a lot of different stuff that we can
You're
do.
saying things that below your mantle.
Yeah, well. Well, one of the kind of curious things is that I don't really have an answer for this. Is I actually wonder how much rendering architecture has been influenced just the fact you couldn't issue a lot of batches, and because you couldn't. I mean, how many times I've seen? I think I saw a presentation and a thing where, well, we can't do this because that would increase batches, and I'm like, that's kind of unfortunate. And so we probably lost some visual quality just because people have. It has been a concern.
In generic engines, what serial bottlenecks are allowed? If you can say generic engines.
Yeah, well, let's see. Can we really talk about that? So let's talk in more general terms. I think the place where most people have difficulty parallelizing is in AI and in gameplay. It's in the game design. And part of this is because a lot of the people that are working in the game design and in the gameplay area are truly trying to balance two things. They're trying to balance fun and experience, and at the same time they're really trying to write performant code, which is quite honestly, the first is an art form, and the second, trying to add a difficult task on top of an art form, becomes very, very complicated. So I would say that a lot of the other tasks, physics processing, it's relatively straightforward to parallelize. There's a lot of animation, like there's a lot of things that is pretty simple to parallelize, and you don't have to worry about switching that around a lot. Right, gameplay, you're going to make big decisions. You're going to make them very quick. You're going to, in some cases, try them out very quickly. So I think that's one of the areas where a lot of people wind up having a struggle. Is really just trying to paralyze fun.
But I would definitely say, right, that like if you look at most of the traditional engine architectures, there's definitely like gameplay stuff that you can parallelize the ARM. Like so, your game object or entity update loop tends to just be in one thread, and there's no reason. I mean, most update loops, you can't really assume an ordered update anyway, so you like each entity sort of has to assume that it's fairly doing its own thing, so there's no reason why you couldn't have that running in 3 threads or 4 threads and have a lot more objects, which is assuming what's happening in your engine, because you have thousands of spaceships flying around.
Yeah, it's very bizarre. No one knows what core they're running on at any given point in time, so it's very interesting.
Yeah, it would almost be like you'd have to write something that would be sort of, you get put in different buckets, right? Like if your update is important, then you're in a different bucket, and then if your update isn't important, you just get thrown in and you go in this thread or that thread, it's whatever's.
Yeah, the difficulty is that there's the potential for serialization, right? And a lot of times gameplay and the AI guys think very serially. So trying to have that go wide without having contention what's it being.
It was also game to go was also the biggest challenge for us doing the launch titles now for the next generation consoles. That's the thing that's been the most of most of the people are focusing on optimizing, was focusing on game to go. Then it's also a tricky part of it is both the fun aspect that is to describe, but it's also that it's huge amounts of code that we have, and it's all just intermingled and then interacting in various ways. I'm really happy we actually found solutions, and you guys have as well, of being able to extract out parallelism there, of identifying the things that are independent. So we sort of have some parts that are synchronous and some parts that are asynchronous, and be able to parallelize on that. So for example, 64 soldiers, well, if you can parallelize quite a big part of your soldiers, you have lots of work to do there. Not so much with other game objects that have a lot of dependencies on them, but it's a really key area. I mean, before we did all of those optimizations, were significantly bottlenecked by just pure gameplay code. Rendering physics, audio, all that animation ran super nicely parallel. Gameplay code was a big bottleneck, and I think you'll see that with quite a few games going forward also, even if they would use Mantle, they quickly would get running into other bottlenecks that we'll have to attack.
Since the announcement of Mantle, there's also been a lot of talk about bindless. To get right to the point then, how much of this could you pull off just bindless, and how much of this do you need Mantle for? How would the two compare in terms of getting rid of the draw call bottleneck?
It's a complicated question.
One thing is the very obvious point is there's nothing to allow better usage of multiple cores. So
Yeah, I mean,
this is already pretty significant.
I think that the thing is, I'm not convinced you're going to get a whole lot of benefit out of it. And the reason why is that if you look at the current DirectX model and the texture arrays, and we're already doing a lot of these things. I mean, Arm's already doing all that stuff. I mean, we're packing all sorts of stuff in like single textures. We have texture arrays we've had since DX10 that have 64 textures simultaneously in the index and the shader. I mean, we've had all sorts of stuff, and we've used it. It's helped a little bit, but I haven't seen any evidence on my standpoint that bindless are some kind of panacea or magic bullet. I actually think it makes, I mean, I'm a little contrary, but I actually think it makes it harder to architect your engine because if you think of a batch as a function call, you're kind of asking the entire engine to make everything global, and generally we consider that bad form. Generally you want to pass some parameters into it and then have it execute. I mean, so I'm not sure that even if that could mitigate overhead, it's the right thing. The other thing is it definitely introduces overhead in the shader. So you are, even in bindless, you're going to sacrifice GPU performance or CPU performance, which is an unfortunate thing.
And it also doesn't attack many of the other things that that Mantle does. For example, the things with the monolithic shader pipelines and overall memory management and getting away from these large driver threads. That we want to have a really stall-free experience of playing our games, and bindless can help with performance on one part potentially, and actually some really interesting programmability options with that. But actually having an solution that overall improves things there and switches the model. That's a lot more.
I don't know how is it for you, but like I think like we probably only switch textures one out of every like 30 batch. I mean, we don't.
Well, for now.
Yeah.
I mean,
It's not like that's what's slowing us down, as far as I can tell.
But one thing to know is that, so the conventional binding model, right, and bindless, they have different trade-offs, right? What Mantle gives you, and this is again in the spirit of just giving the right tools, and we hand out a whole spectrum of tools, and you can use the binding model to optimize for whatever target you want, right? Anything from conventional binding model to bindless, and anything in between, so you can trade a CPU versus a GPU performance, right? At the very fine-grained balance to actually match whatever content and whatever bottlenecks you have. So just giving you more tools to really hit, because as it was brought up that you squish one bottleneck and it'll pop up somewhere else. This is about flexibility and being able to target bottlenecks and really try to create as level of a field as possible without anything sticking out.
I think a big difference there is bindless is really more the approach like we have an API, it works, we see it's really slow. So yeah, in the API, in the graphics API as a whole, let's find one thing, how we handle texture different, let's fix that. And that will make the problem go away. Well, no, it will make it a little bit better. And
we got like 10%.
So, and the difference with Mantle is really now just saying, okay, let's kind of start from scratch. Let's say, okay, how would we like to drive it? And so so all these bottlenecks kind of disappear as opposed to individually picking at each single one of them. And well, for example, like doing the threading, when the attempt was made to do that at DX11, we see how well that has worked out. So yes, let's try bindless, and we'll see that gives us another 5%, and then let's have big discussions again, and we'll see how long, like a few years later, we'll probably try something else. And yeah, maybe 20 years from now, we'll have an efficient graphics API. So I think it's just saying, start from scratch, do this, do something that's efficient, do 100K draws, see that works. I think that's really where the power is.
There's a lot of things we know of how things really should work, both from your side. You guys have been working for a long time building massive drivers, and we've been working a long time trying to collaborate and work with those drivers, and just scratch it, think of how you really want things to work. And there you have Mantle.
Right, and it's a good proof point that it can be done, right? I think the biggest challenge was to break the stigma that we've reached the performance, right? And everybody kind of thought, I mean, certainly not you guys, right? You were believers, right? And this is what kind of helped us to really stand there and say, you know what, I'm not crazy. You know, I'm not the only one in the industry who thinks that we can do better, right? And it's really this collaboration that have enabled us to really showcase to the whole industry, indeed, this can be done.
Okay.
More Charlie. Oh, wait, do we have someone over here? Was it? Yeah.
can you elaborate more? We know Mantle is great, but can you elaborate more about what benefits can Mantle project bring to the developers and players? And does AMD have any requirements if the game developer wants to join the project Mantle?
That's good for you, Gana.
Yes. So I'll start kind of backwards from the last question. As far as the requirements, I guess you have to be passionate about gaming and reaching the best performance there is there. But seriously, no, there are really no requirements. We are working very closely with a limited set of developers right now because we wanted to focus on delivering a solution to make it those proof points, right? And we couldn't really spread our focus. So we've been very focused, working with Johan and Dan and Nix's guys as well, because we needed to have a proof point, right? And I'll sidetrack a little bit. One thing that I've learned over 13 years I've been doing this at ATI and AMD is that other solutions often in the industry have been kind of developed in isolation from developers, right? And what we've tried to do is something completely different. We actually tried, first thing that we've done, we actually sat down with all these guys and many more in the industry and figured out what are the problems, how do we solve those problems, what are the priorities, right? And then we collaborated to figure out how that can be done, right? Based on the experience. And what was the beginning part of the question?
The beginning question was just, can you elaborate more how Mantle can bring benefits to the developers and to the
Where do I
players?
start?
Yeah.
Where do I start? And these guys can probably answer this a lot more, but I'll start to just kind of, I guess, warm it up. Well, there are two ways to look at it, right? Increasing performance means two things, right? First, it means that you can run faster, naturally, on the existing hardware. The other way to look at it is that if I don't need to run faster, can I run it on a lower end hardware? And if I run it on a lower end hardware, how does it expand my user base? So suddenly, maybe everybody with a small form factor, not so powerful notebook can run all these games, right? Extremely expanded user base. So that's one way to look at it, right? The other way is, performance is nice, but to me this is only kind of a stepping stone, because if you're talking about 20% improvements, 2x, even 3x, right? This is just purely performance advantage. When you think about 10x or more, the question you should start asking yourself, what is the new concept I can put on top of this? What new games, and I think Oxide guys have brought it in their slides, what types of games are we missing today, right? User content.
Yeah.
Thank you for no idea. I mean, one of the cool things that we're really interested in as Oxide and exploring is all those types of games you used to have in the late 90s. Remember all those games were like builder games, you could build all sorts of stuff, and a lot of those games never really survived a 3D transition. And I think part of it was just because we couldn't handle the kind of complexity, and we would love to see that the whole kind of the breed of games come back. And I do think a lot of it's just technical. It's just hard to make those sorts of games. There's also a point that Gennady doesn't see that I've seen before in previous projects, rather big projects. That is, it's a lot of work to make a game shippable on a PC. It's a lot of work to deal with all the different drivers. It's a lot of work to make the game reliable. The kind of really irony is that there's all these services offered inside the APIs that are supposed to manage stuff for you, and you can't use any of it because you can't trust it won't crash on you. And people personally blame you when their machine breaks up during a 400-hour session of the game and they forgot to save. And I don't know how many times I just get an error message back from the driver just saying, I give up, I failed. And that's really hard. And I can't debug it. And my producer came to me and said, can you do anything about this? I'm like, I don't know. The driver just died and probably ran to memory. And that's really difficult. So I think one of the benefits you'll get from the lighter driver model is that we can really validate this stuff works a lot better. And by having that control, we can probably deliver, I believe we can deliver a far more reliable product because we can actually validate that these things work.
So I'll ask you a question.
Mm-hmm.
so I mean, you've been using all these pre-alpha drivers and something that I wouldn't even consider stable, right? And these guys have made an amazing stuff on this driver. Can you elaborate on how helpful it was that it's thin, even on the pre-production quality driver?
Oh yeah, it's great being thin. I mean, the hard part for us is I think like probably 75%, 80% of the time I would email my guys, I think there's something wrong, and I'd realize it was my fault. And that's actually great. I mean, because if it's the driver's fault, I can't fix it.
Yeah.
And then you had this situation where you have to go, and I was working on big projects, so we could actually have the drivers get fixed, but then you have to get the users to download it, and you end up having this database. We had a database, one of our projects, of like 300 cards, and the intersection of the drivers that know not to do this feature. I mean, it gets pretty crazy to try and deal with it. And all this stuff is happening, like, average person, and this stuff still breaks, people still blame me. We really try very hard to make it as reliable as possible, but having it really thin like that, most of the time, it was my fault. I think probably of all the bugs, probably 75% I was like, okay, I identified it, and then I think Gennady started ignoring me after a while because he'd just wait a couple of days, and then I say, oh, I figured it out. It was my fault.
It was very similar for us as well. Yeah. Well, sometimes I utilize that to my advantage of, let's have them think about this for a while and see if this is their error. But yeah, typically it was our fault. We were doing something stupid here, and well, in this very early version, the validation layers are not as built up either, and the validation layers will be a great tool. They are already a good tool, but it will be a great tool later on there. And that would have caught some of these things, and other things, having more documentation and learning it. I was a bit lazy about some of the parts and off learning it. But
and actually, a lot of my answers, if you guys remember, have you read this section in the
Yeah.
programmer's guide?
Yeah. So I'll bring up one more point, which I think is really pertinent, just because when you're developing a new product, you're trying out new techniques, you're doing new things. When you've got a large black box driver, the trouble is that the driver guys have never seen this new technique or this new code before. You have no idea how it's going to run. We've run into cases where memory gets put in the wrong location and developers can't work on a certain card. We've had to big cards from people and give them a different vendor because the driver made a mistake. And this is during development. You're not going to get a driver team to optimize their driver for a technique that you even want to try out. Like the amount of stuff, it's really interesting that once you get that control, the amount of techniques you can try out becomes really, really fascinating.
And that's for people who have access and your game's big enough where you'll get the things fixed. I mean, I couldn't imagine what your life must be like as a small developer.
No.
Like you pretty much, you're stuck. You're just gonna have to
You are stuck. I mean, I've been at the small developer developing engines, and I can tell you that it's very, very difficult to get anything to move at that.
And even as a big developer, there are a bunch of techniques. I probably can mention 2-3 different cases of we've developed a new technique. No one has done this before, and every single driver and graphics vendor we tried on, they just crash. And you're sitting there as well, am I doing something wrong here with this here? No, I looked it up and it's supposed to be able to do this. And it crashes or burns in various ways. It's kind of frustrating as a way to develop there. Sure, as a big developer, I can tell the various vendors, I can send them a rebuild, and they will listen to me. But it will take time, and they may, it's really frustrating here. With Mantle is that we have AMD focusing on making sure that the lower levels work, and we can rely on those. And then if it is a higher level problem, well, it's very likely my fault.
And
it could be their fault, but it's a lot more unlikely.
There's kind of general trend of software that it's kind of rule is the less code you have, there's less things that can break.
Yeah.
And so the smaller you can make stuff, it's going to be more reliable and it's going to be faster.
I think it's really important to realize that's also, for the consumer, that's a very big deal. I talked about that in my presentation a little bit. Right now, it's almost expected that we release a game, we use some of these new techniques, and people are like, oh, of course the game crashes for me because I have the driver from 2 weeks ago, and the game just came out, so we probably need a newer driver so that the games will actually work. It's kind of, really, ironically, you get a driver, and the driver is for the hardware, and then you get products that will run on that because the driver is, if the hardware doesn't change, the driver isn't supposed to change. No, the driver is almost a piece of software that sort of is prepared with a game, and if you get a new game, you need a different driver, or maybe switch back to the old driver when you go play the old game again.
That's good proof how dependent we are on each other there, and that it's not a great end user experience. It's not a great experience for neither developer or hardware vendor.
And I think the consumers are really hurt by that, and they have accepted it, but I think that's not a good thing.
Yeah, maybe that explains why drivers are like 300 megabytes now. Like, why? Like, I remember Windows 95.
Drivers are gargantuan because all the hardware it ships on is fundamentally broken. I mean, right, like, no one validates GPUs like CPUs. There's a reason why the driver's that big.
One thing to keep in mind that GPUs are that much more complex than CPUs.
Right, but I mean, it's like, this is sort of a fundamental trade-off, is that as you get closer to the hardware, the validation burden
But
on the hardware.
but that's not true, because keep in mind that D3D runtime validation does not occur in the driver. A lot of that validation occurs in the runtime itself. I mean, there's a huge amount. There's an entire debug runtime that loads. It isn't even part of the driver. So, I mean, a lot of that stuff should be happening at the operating system level. It's not supposed to be there.